So welcome everybody to the Python and Oracle Database Office Hours for January 2019, the first one for 2019. We're kind of scattered around the world a little bit. It's 6 a.m. here for me. I'm Christopher Jones. I do some of the product management in the database access team, looking after some of these drivers like CX Oracle and Node Oracle DB, the PHP drivers. We do a lot of the drivers. Also have Anthony Tuaninga, who's the creator and maintainer of the CX Oracle extension that we'll be talking about today. And then Blaine Carter is an evangelist in our team who does a lot of interesting things at conferences, currently doing a bunch of stuff with Internet of Things devices and I think, as they say in America, soldering irons, as we say in English, soldering irons. So our wider team, just to sort of get everything going, looks after a bunch of these open source scripting languages, as we mentioned there, and then the proprietary APIs into the database. So things like CX Oracle are written on top of our C API into the database. So as you probably know, it's what we call a thick client. You need some instant client technology underneath, or Oracle client technology underneath, to make it connectable to the database. So just today, spend probably no more than half an hour. So just a brief overview for those who haven't attended the office hours. We have a little bit of an icebreaker, the thing we call stuff in the middle, and then really throw it over to you to ask questions for us. And typically a lot of you are quite shy on that, so please be prepared with a question. Just type up something there in the chat, or be prepared to unmute yourself, and then we can go ahead and answer that. So the way you do that, there's a chat somewhere buried in the menu or in the More menu on the right, or you can unmute and talk. Do that at the appropriate time. Icebreaker theme this month is going to be something we actually did cover last year, but there was popular demand last month to cover it again. And so we're going to run straight through that. I am going to throw this over to Anthony to run through. These are effectively his slides. And let me give him mouse control. And I think, Anthony, you should be able to control that now.
We shall see, and hopefully you're not going to get feedback. Any troubles there, Chris? Okay.
Oh, good.
All right, so executemany. This is an old feature, as it shows there. It was first introduced in CX Oracle 2.5, which is well over a decade ago. And the main reason for its existence is to improve performance. When you call cursor.execute, it goes ahead and executes the statement, but that requires a round trip to the database. So we send a request to the database, and then we get a response back. And if you're doing this many, many times, the performance can diminish rapidly. So executemany allows you to do in one round trip what would take many otherwise by calling cursor.execute many times. So the example that's shown here, there are 7 rows here. And instead of calling cursor.execute 7 times, it's called once with executemany, and you get 1 round trip. Right. All right. So array DML row counts is a feature that got added for version 12.1 of Oracle. It's also added in CX Oracle 5.2. And the problem is that if you call cursor.executemany and you take a look at cursor.row count at the end, you will simply get back a sum of the number of rows that were affected. If you want to know how many rows were affected for each individual execution, then you need to use this array DML row counts equals true, as you can see there. That's a feature. And when you're finished, when the execute is completed, then you can get the results by looking at cursor.getArray DML row counts.
So Anthony, what do you mean by affected?
The number of rows that were either inserted or updated or deleted, those sorts of things.
Mm-hmm.
There we go. All right. So this is the SQL that we're using for this example. We're just creating a table, parent table, that has a primary key called parent ID, as you can see on line 2, and a description. And then we have a child table And it also has a primary key called child ID and a foreign key, parent ID, to the parent table that was just created above, and a description as well. So here's the Python example. In line 1, we've created an array called parent IDs to delete. These are the IDs that we intend to delete from the child table. And then in lines 3, 4, and 5, we're calling executemany to delete these rows. And we're enabling array DML row counts. And in line 7, we get the array DML row counts. And then in lines 8 and 9, we're simply iterating over the results. And in the blue box at the bottom, you can see the output that gets displayed. You can see that for parent ID 20, 3 rows were deleted. For 30, 2 rows, and for 50, 4 rows. If you had just called cursor.rowCount afterward, you would have seen instead 3 + 2 + 4, which would be 9.
Anthony, while you're on this slide, do you want to just talk about line 4 a little bit? Because I know people often get a little tricked by what they need to do when they're binding. So you've already got an array there on line 1. Why can't you just pass the array in on line 4?
Right. In order to call cursor.executemany, you need to pass an array of tuples or an array of arrays or a list of lists. So that's what's being built up here. You can see that parent IDs to delete is a simple list. So we have to turn that into either a list of lists or a list of tuples. And in this case, I'm using a list of tuples. And the parenthesis I, comma, parenthesis is a simple way of building a single tuple. Yeah, for those who don't see it very frequently, it looks a little odd to begin with.
Thank you.
Yeah. All right, so another feature that is useful when you're using executemany is batch errors. The problem comes if you call cursor.executemany to insert a lot of rows, say, for example, 500 rows, and there is a problem. And perhaps at the 300th row, one of the rows can't be inserted. Well, if you do that, the whole batch fails, and you get back the error that occurred. Now, if you happen to fix that problem, you go, okay, well, I'll fix that row, I'll remove it, or I'll fix the data in it, or whatever you have to do. And then you reissue the executemany, then the 305th row might fail. And of course, you have to repeat over and over again. So this allows you to have the entire batch run, and then at the end, you can figure out which errors occurred. There we go. So in order to enable this, we use cursor.executemany, but we pass the batch errors equals true parameter. And then afterward, we call cursor.getBatchErrors. Each of the errors that's returned is an error object like you would get from a try except. And you can combine it with the array DML row counts feature we talked about earlier. And like that feature, it's also only available with Oracle database and client at 12.1 or higher. So here's an example. In lines 1 through 7, I've created a list of tuples that I'm going to be passing into my executemany. And I've deliberately introduced some errors. In line 4, you can see a duplicate key. 1018 is repeated there. And in line 6, we've got a parent key that does not exist. That's 75. Again, we call cursor.executemany to insert into our child table, and we set batch errors equals to true. And then in lines 11 and 12, we simply iterate over the batch errors that were received. And you can see them down in that blue box there. You can see the unique constraint violated at row offset 2, and an integrity constraint violation at row offset 4. And those will match exactly the indexes into the array that was passed.
So can I ask a little bit about that and auto commit, and how does that all work? So what happens in that case? Do I get, if I have an auto commit set on, is my data committed?
Yes. tis. Or is it? No.
No, it's not. Sorry, I was asking a leading question.
Yeah.
It's not auto-committed, and that's the little trick there, that even though
Yeah.
it's auto-commit, it's not committed because the database knows that you had some data problems and doesn't want to commit some bad data.
Yeah.
Lets you then go and work out what was wrong with those couple of lines there. Maybe you can reinsert them and then actually do the commit of the whole data batch after that.
Yeah. Yeah, it's obvious that it's not something I deal with frequently.
Or it's
I avoid auto commit generally. So
yeah.
All right, another feature that got added. This is added in CX Oracle 7 was array DML returning. So if you're using batch execution and you want to use the returning clause in an insert statement, for example, that wasn't possible without doing a bunch of tweaks. And it especially wasn't possible if you wanted to return more than one row. So you can now do that. In version 6.3, you could have done it by setting that under, future, under. But, yeah, go ahead.
So is that a question from someone?
Sounded like it.
Yes, sir. Yes, sir.
I'm going to mute.
Oh, Zahur is asking, can we use this feature in simple SQL or PL SQL? And the answer is you can use it in both.
Mm-hmm.
Sir, I'm currently studying SQL. Okay. Yeah. Can we use this feature in simple SQL queries, sir?
You can't use it in queries. Execute many cannot be used with queries.
Yeah.
Only with insert, update, delete, and PL SQL statements.
Yeah. Yes.
Yeah.
Sir, if you have no knowledge of Python, sir, can we study Oracle?
If you don't know Python, of course you can use Oracle.
Yeah, this is my question.
Yeah. So we have some resources out there. We don't yet have a user manual. I know that's being worked on, but there are some resources, a lot of information, a lot of users. So certainly it's a good language to learn if you're new to it, and no problems using Oracle at all. Let's continue on. Maybe then you could finish up afterwards, ask questions when we throw it back to users. I'm going to mute you now for the moment.
All right, so here's the example for using array DML returning. You'll know it looks very, very similar to the array DML row counts. In fact, it's practically identical in terms of what it does, the same delete statement. But in this case, instead of just getting the number of rows that are being deleted, we're actually getting the actual row, information about the actual rows that are deleted. So you'll see in line 1, again, parent IDs to delete is the same numbers, 20, 30, and 50. And then in lines 3 and 4, we're creating a variable. That's so that we can return the data. And the array size of that data is going to be the number of executions that we intend to make. So in this case, the length of the parent IDs to delete list. And cursor.set input sizes on line 4 is simply to identify the variable so we don't have to pass it into our array over and over again. You'll note there's a none at the beginning there, and the none simply states that we should just let CX Oracle pick the variable, the data type that it wants to use, and it bases that on the input data. We could also have used int there and would have had exactly the same effect. So in lines 6 and 7, again, we're calling execute many. And then in lines 9 and 10, we are iterating over the results. And you can see that in the blue box below, where parent ID 20 deleted the children, 1002, 1003, 1004, and likewise with 30 and 50. So you can see the exact data that was deleted. What was your question, Chris?
I just wanted to speak a little bit about the 6.3 versus 7. So this is, I guess, is technically a new feature in 7. There was a sort of half-working version in version 6 of CX Oracle, and that's why you had to introduce that extra flag there, because you wanted to change the behavior so you could have a fully working version in 7.
Right.
You needed to be able to support it. So I guess it's a sort of backward compatibility break between 6 and 7.
Yes.
You can prepare yourself for it by setting the flag, which was on the earlier slide, that from futures flag.
Yeah.
And
Yeah, in the previous versions, in version 6 and earlier, if you tried to do this sort of thing, you would basically get one of those values returned. So you'd get like 1002, 1005, 1012, and that's all you would get. So now when you look at it, you get these lists. So.
And can you just, for my sake, because I don't use Python day to day since I have a lot of other languages and roles, can you explain line 3 and 4 again to me, because they are worth going over. Certainly, I know we will have new people here on this call.
Yep. Well, line 3 is creating a variable. Variables are used for passing data out generally, although you can use them to pass data in as well.
Which is what's happening here, right? You're passing data in.
Out.
Oh, yeah, sorry.
Out.
Okay, yeah, sorry. You're doing both ways, out and in, but this is for the out bit of the.
Yeah. This is for the returning clause.
Yep.
So, yeah. So the array size there is simply the number of elements in that variable that we're creating. So when you're doing a bind, a regular cursor.execute, the value will always be 1. But if you're calling executemany, the number of iterations, so the number of times that delete statement is going to be called, is the size of the array size. So in this case, 3. Yeah. And then again, line 4, setting input sizes, that simply defines the memory areas in advance. So none simply says, just let CX Oracle do its normal behavior. And then the var is saying, but for the second bind variable, which is for the returning clause, use the variable that we've defined. Instead of calling cursor to set input sizes, we could have also done in line 7, I, var. That would also have worked, but that's just overhead. So I don't do it that way.
Thank you.
Yep.
Put some resources up for those people who want to drop off. One thing I will actually just briefly show you while we're waiting, if I had this toggle up here, was this. I know we're interested in languages and drivers. So this is a Oracle driver, Oracle API for the Julia language. So another machine kind of processing language. So this is just coming along. And like all good open source software, it has a promise that something is going to happen. And then we'll see whether that actually happens. But certainly there is activity on this. So this API, this driver, is based on what we call the ODPI-C API, which is also used by Python. It's a wrapper around a lower level, which makes it easier to write drivers. So it's actually got a lot of technology available to it immediately. So if you're kind of interested in machine learning, things like that, and data analysis, it'd be interesting to see where Julia goes to.